Hello friends, this is Lokesh Babu. Welcome to my channel Lokesh Max Hub. Thank you for all of you for watching my videos. Friends, today I came with a super duper topic, Fourier series. Fourier series. See, Fourier series is very important for engineering students. It is compulsory subject almost all in all universities in India. Either it is in BTech first year or in second year, it is compulsory topic. Not only in this BTech, so for every competitive exams, you may expect one or two questions compulsory from this topic, right? So it is very important. So please take pen and paper, pen and notebook if you want to learn this concept, right? And give me half an hour time and I will try to make you perfect in the Fourier series. So this is the lecture 1 in the Fourier series, right? So please concentrate. Let's start the class. Fourier series is an infinite series representation of periodic functions in terms of the trigonometric sine and cosine functions. Fourier series is an infinite series. You know the sequence and series. See, for example, 1 plus 2 plus 3 plus 4 plus so on. So what is this? Sum of the first n natural numbers. You can write n into n plus 1 by 2. Right? N into n plus 1 by 2. So this is a series, infinite series. It means we can express a periodic function in terms of sine and cosine function. We can express a periodic function as a Fourier series by using sine and cosine functions, right? If we take for example x square or x cube, x square is a periodic function. We can express x square as a Fourier series by using sine and cosine terms, right? Now, what is the use of this Fourier series? Fourier series is very powerful method to solve ordinary and partial differential equations. So by using Fourier series we can solve ordinary and partial differential equations, particularly with periodic functions appearing as non-homogeneous terms. See, we will discuss what is ODE and PDE, ordinary differential equation or partial differential equation, non-homogeneous differential equation, in another video. Now, Fourier series is useful to solve ODE and PDE, particularly in the periodic functions, right? Now, what is this periodic function? See, periodic function definition. A function f of x is said to be periodic function if f of x equal to f of x plus t. A function f of x is said to be periodic if f of x equal to f of x plus t. It means if you write f of x plus t, then you will get again f of x only. Then this t, the least value t, is called the period of this function f of x, right? If f of x equal to f of x plus t, then t is called the period of this function f of x. For example, sin x, cos x are the periodic functions with period 2 pi. Sin x is a periodic function with period 2 pi. See, let us draw the graph of sin x. See, you know the sin x graph is like this. It is 0, pi, this is 2 pi. So the curve is in this shape. So if you move this curve from 2 pi to 4 pi, again you will get the same image, same curve. So from 0 to 2 pi you will get the same curve, and from 2 pi to 4 pi also you will get the same curve. It means this function, this sin x graph is repeating, this graph is repeating for every 2 pi interval, 2 pi, from 2 pi to 4 pi again 2 pi interval. So for every 2 pi interval, for every 2 pi difference, the curve, the graph is repeating. It means the sin x is a function which repeats. Of course in the negative side also it repeats, right? So this sin x is repeats for every 2 pi interval. Therefore this is called the periodic function. I think you understood clearly, right? Right. Now to express any function as a Fourier series, to express any function f of x equal to, let us suppose, x square or pi minus x, whatever it may be, as a Fourier series, we need some important formulas, the basic formulas. Easily you can understand, already you know that. Just once let us repeat. These are the important formulas. Sin 0 equal to 0, you know this. Sin 0 is always 0. So sin n pi value is also 0. Cos 0 value is 1, right? Cos n pi value is minus 1 whole power of this n, and cos 1 pi, I am writing in the place of n 1. Cos 1 pi is minus 1 whole power of 1, so that is minus 1. Cos 2 pi is minus 1 whole square, that equal to, you will get plus 1. So basic formulas, you know already this. Now differentiation of cos x, you know this. What is minus sin x? Integration of cos is plus sin x. Differentiation of sin is cos x, and integration of sin x dx equal to minus cos x. Because if you know this, then if you revise this once, then easily we can solve the problem. And we know the integration formula, integration by parts, integral of u v dv equal to u into v1 minus plus minus plus minus. In this way you can write, first of all, u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4. This u dash, u double dash, u triple dash are differentiation, and v1, v2, v3 we are the integration. You know this. Otherwise you can use this formula also, integral of u v dv equal to u integral of v minus whole integration of u dash integration of this v dv, right? One more formula, important formula, integration of e power ax into sin bx dx. This equal to e power ax by a square plus b square into a sin bx minus b cos bx, right? Similarly, integration e power ax into cos bx dx equal to e power ax by a square plus b square into a cos bx plus b sin bx. So these are the some formulas which are very much useful to express a function in terms of Fourier series, as a Fourier series, right? So now, so I think you understood this. So after this I will express the Fourier series in different interval. Let us see that. Now see here, Fourier series. Fourier series is a periodic function, you know this, with the interval 12. Fourier series I will write here. Fourier series is a periodic function with period 12 in the interval alpha comma alpha plus 12. You can take L as capital also, no problem, right? Fourier series is a periodic function with period 12 in the interval alpha to alpha plus 12. Then the Fourier series expression is f of x equal to a naught by 2 plus summation n is 1 to infinity an cos nx plus summation n is 1 to infinity bn into sin nx. This is the Fourier series formula, where this a naught, an and bn are called Fourier coefficients. These are called Fourier coefficients, right? Now here a naught is 1 by L into what is the interval alpha to alpha plus 12 into f of x dx. This is the a naught value. An equal to 1 by L into alpha to alpha plus 12 f of x into cos nx dx. Similarly bn equal to 1 by L into alpha to alpha plus 12 f of x into sin nx dx. Sin nx dx. These are the formulas which are obtained by Euler's formula. From Euler's formula we obtained this a naught, an and bn values, right? Now I can express these values in different intervals. See, for example, let us suppose Fourier series f of x is where the general limits is alpha to alpha plus 12. I can express this f of x in different intervals. So I am writing like this. First of all, I can express this in interval 0 to 12 and minus L to L and 0 to 2 pi and minus pi to pi. From this you can understand clearly the Fourier series formulas a naught, an, bn value. Then easily you can solve the problems, right? Now see here. In the interval 0 to 12 means what? 0 to 12. This is the general. In this 0 to 12, it means what? Alpha value is 0. Alpha value is 0. And 2L, alpha is 0, L is L only. L value is L. So substitute these alpha is 0 and L in this general formulas. Then what you will get? A naught value. Then what is your A naught value? A naught equal to 1 by L alpha to alpha is 0. So you can write 0 to what is this 12? 0 to 12 f of x dx, right? Similarly an 1 by L 0 to 12 f of x into cos n pi. See here, whenever we are expressing this in this interval alpha to alpha 12, then you can write this is cos n pi x by L. So this is cos n pi x by L, general formulas. So cos n pi x by L. Write down like this. Then what is this? Here also cos n pi x by L. Later I can change sin n pi x by L. So these are the general formula in alpha to alpha plus 12, right? So n is 1 to infinity an cos n pi x by L, bn sin n pi x by L, and in this also same cos n pi x by L, sin n pi x by L. Then what you will get here? Since L is L only, therefore this is you will get cos, what you will get here? Cos n pi x by L dx only. Bn value is 1 by L 0 to 12 f of x into sin n pi x by L dx. So these are the a0, an, bn value. No confusion, very clearly. The first value is f of x equal to a0 by 2 summation n is 1 to infinity an cos n pi x by l summation n is 1 to bn sin n pi x by l. These are the formulas from the Euler's formula. So you can write like that. Now in this, if the question is given in this interval 0 to 12, you write down these formulas a0, an, bn value. For example, if the question is given in this interval minus L to L, then how can you write? Then simple, a0 value equal to, what is minus L to L? Alpha value is here minus L. It meaning is alpha value is minus L, and if alpha is minus L plus 12, automatically L. So L value is L only. L value is L same, but alpha value is minus L. So 1 by L, L is same. Alpha value is here minus L to L, f of x dx, right? Similarly, an value is 1 by L minus L to L, f of x into cos n pi x by L dx. Bn value is 1 by L minus L to L, f of x into sin n pi x by L dx. You can write like this, right? Okay. Now, if you want to write these limits in 0 to 2 pi, in this 0 to 2 pi, then what? If I want to write in 0 to 2 pi, it means in the interval 0 to 2 pi. If I want to write, let us suppose this is case 1. To understand easily, case 1, case 2, this is case 3, this is case 4, right? 4 cases. What is this case 3? I can write this is case 3. In case 3, 0 to 2 pi means what? 0, alpha value is 0, 2 pi, alpha is 0, 2 pi, alpha is 0, 2 pi means L is pi. So L value is pi in this. Alpha is 0, alpha equal to 0, and L value is pi. So now substitute L value is pi, therefore this is a0 is 1 by pi into L value is 0. So 0 to what is this? L value is pi, means 0 to 2 pi f of x dx, right? An is 1 by L, 1 by pi into 0 to 2 pi f of x into cos n pi x by L dx. But L value is pi, no? So what I can write? L value is pi, so I can write pi, but pi cancel, right? So what you will get here? What is the next step? Here 1 by pi into 0 to 2 pi f of x into cos nx dx only. That's all. And bn value is 1 by pi into 0 to 2 pi f of x into sin nx dx only, because pi cancel again, right? 1 by pi, L value is pi. L value pi, you substitute in the general formulas, it is this one, right? Next, last one is minus pi to pi. So if I want to write minus pi to pi in this, now see here, what is the case 4? If I want to write minus pi to pi, it means alpha plus 12, general formulas, general limits. So alpha equal to minus pi, and minus pi, L value is pi. Alpha value is minus pi, L value is pi. Then what is a0? A0 is 1 by L value is pi, 1 by pi into alpha is minus pi to pi f of x dx, right? And what is an? An is 1 by L, L value is pi into 0 to, not 0, sorry, what is this? Minus L, minus pi to pi f of x into cos nx dx only, because n pi x pi, L value is pi, no, pi cancel. right? What is this? Cos n pi x by L. L value is pi here. Pi cancel, you will get cos n x only. Bn equal to 1 by pi into minus pi to pi f of x into sin nx dx. So in this way we can understand all the Fourier series formulas in 4 intervals. So whatever it may be the problem, whatever it may be the interval, without any confusion you can write Fourier coefficient formulas. Clear? Because if it is 0 to 2 pi, case 1 you can write, 0 to minus L to L also you can write, second case. Third case is 0 to 2 pi. 0 to when alpha is 0 to 2 pi f of x dx, 1 by pi 0 to 2 pi f of x cos nx f of x into sin nx dx, right? So very clear the Fourier coefficients in 4 cases, right? Now we have the small properties for this Fourier series, right? So what is the properties? You know this from intermediate, we have a formula. If it is minus a to a f of x dx, then you can write this is 2 times of 0 to a f of x dx if f of x is even function, right? And this is 0, this value is 0, minus a to a f of x dx value is 0 if f of x value is odd function, right? If f of x is odd function, the value is 0. If f of x is even function, then this value is 2 times of 0 to a f of x dx, right? Now let us see what is even and odd function. What is even function and what is odd function? Even function and odd function. See, if any function is like f of minus x equal to f of x, in the place of x I am writing minus x, f of minus x equal to, again and you will get f of x only, then the function is called even function. Whereas f of minus x equal to minus of f of x, f of minus x equal to minus of f of x, then that function is called odd function, right? Clear? See here, let us give me some example. See, for example, f of x equal to even function x square, x power 4 and cos x, these all are even functions. Let us see x square, f of minus x equal to minus x whole square, minus minus plus you will get again x square only. See, let us suppose cos x, f of minus x equal to cos of minus x, this is nothing but cos x, so this is also even function, these are even functions. Let us see for example, f of x equal to x, x cube and so on and sin x, these are the odd functions. F of minus x equal to minus x whole cube, this is minus x cube, this is nothing but minus f of x, minus f of x, so therefore this x cube is odd function. F of sin of minus x equal to minus sin x, this is minus f of x, so therefore it is odd function, right? Clear? So you know what is even function and what is odd function. If it is even function, in your Fourier series we can find only a naught value and a n value only. If it is f of x is odd function, you will have only bn, right? Let us see here. If it is even function, you have a naught value is 1 by pi. I am taking in some interval, let us say I am taking in the interval minus pi to pi. If I take in the interval minus pi to pi, then a naught value is 1 by pi into minus pi to pi f of x dx, this is the a naught value if it is even function, and a n equal to 1 by pi into minus pi to pi f of x into cos nx dx, right? And we have one more, I will give the note as a note here. In the Fourier series, the product of as a property, otherwise property 2, this is, write down as a property 2, the product of even and odd functions is nothing but odd function. The product of even and odd function is compulsory odd function, right? So therefore an equal to 1 by pi into minus pi to pi f of x dx. If it is even function, f of x is even function, let us suppose I am taking plus into cos also even function, plus into plus you will get plus, even function this is. Since it is even function, according to first property, what you can write, this is 1 by pi into 2 times of 0 to pi f of x dx, f of x into cos nx dx you can write, it cannot be 0. If you write bn 1 by pi into minus pi to pi f of x into sin nx dx. See this one, you know f of x is even function, f of x is even plus, sin is odd function means minus, this is odd function, you know, odd function, f of x is even function. So plus into minus you will get minus means odd function. If it is odd, according to property 1, minus a to a f of x dx value, this total value is 0. Very clear. See once again, if it is even function, you will get a naught value and an value only, but bn value is 0. So we cannot find, no need to find bn value because it is 0. So very clear, if it is even function, we will get only a naught and an. Now if it is odd function, we have only bn value. Now let us see what is bn. Same interval, I will take minus pi to pi in this interval, 1 by pi into minus pi to pi f of x into sin nx dx. See f of x is odd function, minus into sin x also odd function, minus, so minus into minus you will get plus, even function. So you have this 1 by pi into 2 times of 0 to pi f of x into sin nx dx. So we will get bn value. If you want to find an value in this, 1 by pi into minus pi to pi f of x into cos, but f of x is odd, right? If you want to find an value for this, an equal to 1 by pi into, in this odd function, 1 by pi into minus pi to pi f of x into sin nx dx. It is odd function, negative, this f of x into an value, 1 by pi into minus pi to pi f of x into cos nx, already this is over, f of x into cos nx. So minus into plus you will get minus means odd function, since it is odd, by property 1 it is 0, by property 1 the value is 0. So n is 0. Similarly you will get a naught also 0. So very clear, if it is even function we have only a naught and an, if it is odd function we will have only bn, right? So with this, what we understood, we know what is Fourier series, right? And formula of f of x value in general limit alpha comma alpha plus 12, we have a naught, an, bn value. And the next we have Fourier series in 4 intervals, 0 to 2 pi, minus L, 0 to 12, minus L to L, right? And 0 to 2 pi, minus pi to pi, case 1, case 2, case 3, case 4, you can find. Whatever the problem in any interval, use the formulas, you can solve the problem. And you know what is even function and odd function, right? If any function is given, easily we can identify even and odd function. Let us suppose x sin x, the question, x sin x, x is odd function, sin x is odd function, so we will get even 0, right? So in this way you can find Fourier series, and we know what is the even function and odd function also, right? So I hope you understood this video, right? So if you understood, if you like this video, please share and subscribe my channel. And if you didn't understand, please watch once again from the starting to ending till the end carefully and write down the notes, practice, and if you have any doubts in this, please comment in the below description, so I will give you answers for that. Right? Thank you friends. Thank you for all of you.